In this video, we'll talk about derivatives for parametric curves. Let x equals f of t and y equals g of t, where both f and g are differentiable on a closed interval ab. Then the slope of the tangent line to the curve at the point corresponding to t is dy dx equals dy dt over dx dt, which, knowing that y is written as a function of t, then we have the derivative g prime of t, and then over f prime of t, providing f prime of t is not equal to 0. And here you have a picture of a function, and then you have the slope of the secant line, the one that is going through 2 points on the graph, and then you have the slope of the tangent line, which is dy dx equal to g prime of t over f prime of t. So basically we can find the slope of a curve written in parametric form. So let's solve this example. Find dy dx for the following curve. X equals 3 plus t and y equals 1 minus t, t greater than or equal to 0. So dy dx is given by dy dt over dx dt. So I'm going to calculate dy dt separately, and dy dt is the derivative of 1 minus t with respect to t is -1. Dx dt is the derivative of x with respect to t, it's 1. So the answer for dy dx is -1 over 1, which means -1. So I made a quick sketch of the curve. I gave to t values 0, 1, 2, 3, and based on the t I found the x and y, and then I plotted each pair. So 3, 1 is this point, 4, 0 is this point, and now we can see from the graph how the slope the slope of this line is -1. To get from this point to this point, we go down 1 and over to the right one, which makes it the slope -1. Let's solve another problem. Find an equation of the line tangent to the curve x equals f of t equals t squared minus 1 and y equals g of t equals t cubed plus t at the point corresponding to t equals 2. So if I want to find the equation of a line tangent to the curve, I do need the slope. So the slope is given by dy dx, so which is dy dt over dx dt. Now dy dt is going to be 3t squared plus 1, and dx dt is going to be 2t, and I want to evaluate this at t equals 2, so then this slope is going to be 3 times 4 plus 1 over 4, so it's 13 over 4. And now we are going to use the equation of a line passing through a point given a slope. So when t equals 2, then x equals f of 2 equals 4 minus 1, which is 3, and y equals g of 2, which is 2 to the third plus 2, so that is 10. So we are trying to find the equation of a line that has the slope 13 over 4 and it's passing through 310, which uses the formula y minus y1 equals m times x minus x1. So we have y minus 10 equals 13 over 4 times x minus 3. So doing the algebra, we get the equation in slope form, slope-intercept form, as y equals 13 over 4x plus 1/4. Let's solve another example. Find all points at which the curve x equals 2 cosine t, y equals 2 sine t has slope 1. Well, first of all, let's remember that this is actually the equation of a circle with center at the origin with radius 4, right? If we square each of them, we get x squared plus y squared equals 4 cosine squared of t plus 4 sine squared of t, which is equal to 4. So let's use the information that is given. The slope is 1. So let's start with slope. dy dx, it's actually dy dt over dx dt. So dy dt is 2 cosine t, and dx dt is differentiating x, so we get negative 2 sine of t, which gives us negative cotangent t, but that is equal to 1 because it was given in the problem. So that means cosine of cotangent of t equals negative 1, or t equals arc cotangent of negative 1, or t equals negative arc cotangent of t, just because cotangent and its inverse are odd functions. So we are looking for the values that give us negative arc cotangent of 1. So we are looking for the values of t that are equal to negative arc cotangent of 1. So cotangent of what value is 1? Well, actually of pi over 4. So I copy the negative and then pi over 4. But also cotangent, it's a periodic function with period pi. So that means another value for t is negative pi over 4 plus pi, which is 3 pi over 4. And another one is negative pi over 4 plus 2 pi, which is 7 pi over 4. So we found out t equals negative pi over 4, t equals 3 pi over 4, t equals 7 pi over 4. So we want to find out what are the x and y values for this t. So let's draw the unit circle and let's try to locate the points. So x or y, it's a radius 4, it's center at the origin, so this would be the circle. And now negative pi over 4 would be this point. So we will want to find out the coordinates of this point. 3 pi over 4, well, this would be pi over 4, this would be 2 pi over 4, and 3 pi over 4 would be the exact opposite point. So we would want to find out the coordinates of this point. And 7 pi over 4 would be, well, 1, 2, 3, 4, 5, 6, 7, so back to this point. So the 2 points that we actually want to find the coordinates for, the x and y, are these 2. We located the points. Let's find x and y. So for t equals negative pi over 4, x equals 2 cosine of t, so 2 cosine of negative pi over 4. So it's 2 times cosine, it's an even function, so cosine of negative pi over 4 equals cosine of pi over 4, which is square root of 2 over 2, so it's square root of 2. And y equals 2 sine of negative pi over 4, that is 2, we know sine is an odd function, so it's negative. Sine of pi over 4 is square root of 2 over 2, so we get minus square root of 2. So the point of at t equals negative pi over 4, it's of coordinate square root of 2, negative square root of 2, and it does make sense because x is positive and y is negative. And let's try to figure out the other one. So for t equals 3 pi over 4, we have x equals 2 cosine of 3 pi over 4, which is equal to 2 times. So I'm looking at this angle. So we are in the second quadrant. All students take calculus. So that means sine is positive, cosine is negative. The reference angle is pi over 4. So basically this is 2 times negative cosine of pi over 4. So that means negative 2 times square root of 2 over 2, which is negative square root of 2. The x is a negative value, and it does make sense. Then y equals 2 sine of 3 pi over 4, and that is equal to 2 times, so sine is positive in the second quadrant, the reference angle is pi over 4, so sine of 3 pi over 4 is equal to sine of pi over 4, so it's 2 times square root of 2 over 2, which is square root of 2. So the coordinates that we are looking for are negative square root of 2, square root of 2. And again, it does make sense. So the answer to the question, what are the find all points at which the curve has slope 1, we found them. Well, we just solved the problem to the left where we were able to find the points of the curve x equals 2 cosine t, y equals 2 sine t, which had slope 1. And so it was easier for us to find it because having cotangent of t equals 1, we were able to find our cotangent of 1 because it was a formula or a value that was pretty common, so it gave us pi over 4. But what if we want to find all the points at which the curve x equals 2 cosine t, y equals 2 sine t has slope 1/4, which would create cosine of t equals negative 1/4, which it's not a common value. So what would we do? Well, we can solve this problem this way. We can start with the fact that this is giving us the equation of a circle, x squared plus y squared equals 4. So the equation of a circle centered at the origin with radius 4. Now if we differentiate with respect to x, we get 2x plus 2y times dy dx equals 0. dy dx is given its slope 1/4, so 2x plus 2y times 1/4 equals 0, which means 2x plus y over 2 equals 0, or y equals negative 4x. So if we replace negative 4x back into the equation, we get x squared plus 16x squared equals 4, or 17x squared equals 4, or x squared equals 4 over 17, which gives us x equals plus minus 2 over square root of 17. So if x equals 2 over square root of 17, then y equals negative 8 over square root of 17, given this relation. So one of the points that at which the slope is 1/4 is 2 over square root of 17 and negative 8 over square root of 17. And if x equals negative 2 over square root of 17, y equals 8 over square root of 17, which makes the coordinates of the point negative 2 over square root of 17 and 8 over square root of 17.